All righty, welcome to SLiTHER number 48. We're talking about getting organometallic chemistry kind of courses into the undergraduate curriculum. Thanks everyone who's here in person and anyone that watches this later on. Tell you a little bit about my course and experience. Hopefully we'll get some insight and other things from our participants as we go along. People that are here live, please feel free to stop me at any point in time if you have a question or you want to add something to it. This is certainly going to be better the less I talk for sure. I know this is coming towards the end of the semester. Some of you are probably already done at this point, in which case I am bitter and jealous. I'm about 2 weeks out and only have to do this and finish a visitor search and do all kinds of things in the next 2 weeks. So the less I talk, the better. So what do I teach in my quote unquote organometallic course? Well, let's talk a little bit about my curriculum in general. So we have the landscape here to talk about. There are two inorganic courses out there, and I know that makes some people jealous. Claude and I were talking here before we got things rolling. But I do have two courses. One of them is a quote unquote sophomore level foundation course. Numbering wise, it's sophomore level. It's a course where I have anywhere from first years to seniors in it and everything in between. But traditionally, in the normal mapped out kind of scheduling, it would be sophomore year. That's kind of my catch all. We cover everything possible in inorganic chemistry in one semester kind of course. So kind of starts with little sort of baby quantum moving into little group theory, molecular orbitals, and then we hit solids and then coordination chemistry and a little bioinorganic at the end. So a smattering of different kind of topics. And then my senior level advanced course, that one is pretty much an organometallic course. That's what I like, and I get to decide what I teach in it, so that's what I teach. All right, so little details on this particular course. The enrollment tends to be around 8 students per semester. It is required for our BS chemistry majors. It is not required for our other majors, which would be AB chemistry or AB biochemistry or BS biochemistry. But normally I do get a few of the BS biochemistry and some of the ABs that take it because they want to take it and or it has a special designation that I'll touch on a little bit later on that they need for their Common Core courses. So that's how we get a few more people into it. The class currently meets 4 times a week for 50 minutes. Lafayette does not have a traditional, or maybe it is traditional, I don't know. It doesn't have a normal credit system. A course is a course is a course. You need 32, there it is, 32 courses to graduate in 4 years. So essentially every course is a 4-credit course in what I consider to be a more normal system. Most courses are scheduled for 3 hours. So there's this mystical 4th hour that is supposed to happen somehow. Some courses go with an actual scheduled 4th hour. This is one of those courses. So that's why it's 4 times a week for 50 minutes a week. We have 14-week semesters. I use George Stanley's book that's on Viper, and book in quotes. It's sort of a book, sort of a PowerPoints through an entire course. I use that as my textbook, so it's all available on my learning management system, Moodle. I also use my LibreText that I use in my sophomore course as kind of a supplement. So students have no money invested in taking the course other than tuition. The various assessments I use in the course are the following. There are 3 exams throughout the semester. There's a final exam as scheduled by the registrar. We do 8 problem sets during the course of the semester. These we generally discuss in class, and they usually takes up about the whole class to discuss them. And there are things that I grade more on, did you give me any kind of reasonable effort, than did you get the right answer? We then do literature discussions, 8 of them. These are all posted on Viper, and I'll dive into what specific ones I'm doing right now a little bit more here in a few minutes. These also take a full class period when we do them. And generally, I do them in a format where the students have a paper with a few guiding questions that they're expected to answer and turn in before class. Again, these are kind of assessed with a, did you do any kind of reasonable work in handing it in, as opposed to, are you correct? And then we talk through some other questions that I make available to them in class. And there it's more graded on, are you actively participating in the discussion, sort of things. There are then 2 papers, aptly titled Paper 1 and Paper 2. I'll talk about those a little bit more. But as I kind of hinted at, this course does have a special designation in our curriculum. It's a W, or writing intensive course. That is by choice. So the students have to do a total of 20 pages of process writing during the course of the semester, meaning they give me drafts, I give them feedback. So the rough outline for the course. Well, not terribly surprising, we start with electron counting. It's something that organometallic chemists generally like to do a lot. We talk about L ligands and X ligands, occasional Z ligands. We talk about valencies. I use the covalent bond classification method of electron counting. There's some great materials on Viper for that. And there is another SLiTHEr on doing that if you're unfamiliar with it, which is a great introduction. And one of our audience members was responsible for that awesome SLiTHEr. So I'd encourage you to check that out if you're not sure what I mean by covalent bond classification. That's the first couple of days of the class. So we're really kind of introducing some ligands, talking about electron counts, d electron counts, and those sorts of things. And then we do kind of a tour of ligands. So I talk about a few different types of ligands to start with. We start with carbonyls, spend a fair amount of time in carbonyls with a bit of a detour into group theory. And that is a purposeful choice. I would say in a more traditional organometallic class, you probably wouldn't go down this route. I do go into group theory analysis a bit more here. And, honestly, the reason for it is this. I had never seen group theory when I went to graduate school. And the first course I took was physical inorganic chemistry with a whole lot of group theory. And to say it kicked my butt would be a bit of an understatement. So I think it's important my students see it so they don't have that experience. So we spend some time there talking about vibrational stuff. And we do go into molecular orbitals with group theory a little bit too. Then we go through the organic ligands, alkyl, allyl, alkene, alkyne, rings, alkylidines, that sort of thing. Not a terribly deep dive into all these. We spend quite a bit of time talking about bonding with these, not really reactions. So in both of these cases, it's a bit more on, just how these interact with metals, what's going on, a little bit on characterization, those sorts of things. We'll see a few reactions as we go, but not really focused on reactions so much as introducing the ligands. We hit some others, hydrides, phosphines, for example, spend some time on those. And then from there, we move into various types of reactions. First up, substitution reactions. Just general ligand substitution, associative, dissociative, interchange, those kinds of things. That's something that could be in my sophomore class when we do a little bit on coordination chemistry. I've opted to take it out of the sophomore level class and move it here. It just seemed to fit better overall in the scheme. Plus, then they will have had organic by the time they get here, so I can tell them that SN2 stands for stupid name 2, and SN1 is for stupid name 1, because, associative, dissociative are so much better names. They just make much more sense. We then hit oxidative addition and reductive elimination reactions, kind of a classic standard. Insertion reactions, mainly focused on carbonyl insertion reactions and alkene insertion reactions. Kind of end our tour day reactions with nucleophilic electrophilic attack at ligands, at metals, those sorts of things. And from there, we go into catalysis and hit kind of the biggies: hydroformylation to talk about first, hydrogenation, metathesis polymerization, and then lastly, coupling reactions. And that one is usually remember all this stuff you learned in Orgo 2 where they were telling you a miracle happens in these steps where you make carbon-carbon bonds? Well, we kind of flush out the miracle a little bit. And, palladium is not just a magical box that does things. It's actually participating in some reactions. Some other little bonus topics along the way that come up in my course are the following. MO with group theory, I kind of alluded to that earlier. We spend a little time there. We don't do a deep dive, but we are doing polyatomic molecules, and mostly it's situations where you're talking about systems with hydrogen type outer atoms around your central atom. We don't go too extended beyond that and get into the group theory to do that kind of stuff. Since there isn't really a lab with this, I don't do any kind of computational work with it. It's something I could think about doing. I just haven't opted to as we go. We certainly spend some time talking about multinuclear NMR, phosphorus NMR for sure, but we do hit some other nuclei along the way. I think that's an important part of this. And also talking about variable temperature NMR to some extent. And even just a little bit 2D NMR will come up from time to time. So some of the more advanced techniques, our Orgo classes have traditionally been extremely proton focused. I'm actually a little surprised that, they mentioned you can do carbon, but our students don't really see it in their Orgo classes. So I do like the idea of hitting some of those topics that they might have heard mentioned briefly, but diving into a little bit deeper. X-ray crystallography for sure comes up. Again, we don't go too hardcore into the math behind it. Mostly very kind of practical stuff. What is it? What can you learn from it? What's it look like, sort of things. But I think that's something many organometallic chemists rely on, getting crystal structures. So something we've got to talk about along the way. As for the literature discussions that I use in this class, I mentioned we do 8 of them. And these are where I see my class kind of changing easiest all the time because, it's always fun and easy to find a new paper for them to talk about. There are a couple that I really like. And again, all of these are posted on Viper. A couple that I really like that I think it would be really hard to talk me out of taking out of my class, but it could be done eventually. But usually every year there's at least one, if not 2 or 3, that it's like, okay, it's time for this one to go. We need something new and different. These are, if you're unfamiliar with literature discussions, guided explorations of a paper. So these can be, communication length papers, 1, 2, 3 page kind of things where the students really read and digest all of it. They can be longer papers. or they can be longer papers where you only give them specific sections to read. Totally your choice there. I've got a mixture of all of those different types. But I think it's important the students get experience reading the primary literature, but also remembering that, papers are written for experts in the field. There's a lot of assumed knowledge. So giving our students kind of a blueprint of what to go through, what to pick out. And even in places where it's like, hey, look at this that happened, the authors don't talk about it at all, but it's relying on this fundamental principle we've talked about in class. I think that's really important for them to see. So the first two literature discussions we've used have been on metal carbonyls. The first one comes from the group I was in graduate school. So it's Angelici paper, where they're looking at CP metal carbonyls with varying phosphines. I love that paper because we get to look at how phosphine electron donating ability impacts carbonyl stretching frequencies. So it's just a really beautiful examination of that. There are systems that are monocarbonyls, so there's one IR vibration, makes it really nice and simple, and you can see, oh, look, this is at higher wave numbers, so we know the carbon-oxygen bond is stronger, that sort of thing. We slip in a little bit of our later reaction kind of ideas, because in those papers we're doing protonation of the metal carbonyl compounds. So you're adding H+, you're formally doing an oxidative addition. We don't use the term at that point, but I do set students up to think about, why did the vibrational frequency change so much when you added this proton? Well, let's do the electron counting. And electron counting is a common theme in all the literature discussions I do, so we keep going back to that. The other metal carbonyl paper I talked about this past year was one with some pincer ligands. So it lets us introduce pincer ligands, which are, something that's very common in the literature. But again, we're kind of focused on the carbonyl aspects of it to some extent. The next one is an ethylene coordination paper. It's a really cool paper. I like it a lot, where they're coordinating ethylene to the coinage metals, and you can see the effect of the different coinage metals on ethylene coordination from the C13 NMR. I think it's just really a beautiful paper, really great work, and the pictures are, I think, something students can just really digest. Like, oh wow, look at this. There's one peak in this copper compound, and there's two peaks in the gold compound, because you can see free and coordinated ethylene with gold. In copper, the exchange is so fast, you only see one peak, and it's kind of in the middle of the gold. The two peaks you see in gold. So it's a really cool paper, fun to talk about. The next one is a click catalysis paper. That was a newish one this year. I had introduced it the previous year, right about when quick catalysis, I don't know, it might have done something kind of big. So that was kind of fun to talk about. Again, at this point in the semester, we haven't gotten into catalysis at all, but I'm starting to give students a feel for what people do with these kind of compounds, what bigger picture applications they have. A classic that I love when we really are committed into going into catalysis is the original Monsanto acetic acid process paper. It's old. That provides us some interesting points of discussion in that, but it's a beautiful paper that's, I think, barely 2 pages long. So students appreciate a short paper later in the semester. But it's just great to go through it. It's certainly something the students can pick apart. By this time, it's the 5th one they've done, 6th one they've done. So I think it works really well. We then hit redox switch ROMP catalysis. Again, this is that's ring opening metathesis polymerization, if you're not familiar with ROMP. Again, this is a short little communication, but it's just beautiful. In one form, the catalyst is active. You oxidize it, it's not active. You reduce the catalyst back, it's active. The plots in here are beautiful. And again, it's very interpretable for students. It does have some more advanced kind of topics in it. There's some X-ray absorption kind of stuff that is easy to skirt away from, or it's actually kind of easy to introduce a technique that students probably aren't going to see anywhere else. Because the author, it happens to be a paper from Paula Diaconescu at UCLA. She made a really great plot. It's like, hey, here's the X-ray absorbance for ferrocene and for ferrocenium, and here's our reduced form of the compound. Here's the oxidized form of the compound. Both have ferrocene ligands that are responsible for the redox. They pretty much overlay perfectly. So you can get what you want out of that without diving too deep into the technique. The two newest ones I added this year came about as a result of the Gordon Research Conference. These were topics that came up an awful lot, and I'm like, well, I better include them. If organometallic chemists are interested in them now, we should be talking about them. So one is catalytic defluorination, how to get carbon-fluorine bonds to break. And the second was catalytic depolymerization. If you went to organometallic conferences in the 70s and 80s, it was all about how to make polymers. And now we've got islands of plastic floating around in the Pacific. So now it's all about how do we get rid of polymers and turn them back into something small. All right. I mentioned the W component briefly on that. The papers, first up, an inorganic chemist of my choice. So I pick an inorganic chemist, an organometallic chemist, that I want students to focus on. Generally, this is going to be someone mid-ish, late career. I want them to have enough papers out there with maybe a few different projects that students can look at. It's not just one specific project. Part of that is for my own sanity. Reading 8 papers on the same exact thing can get a little tiresome. So giving them some kind of diversity in their choice, I think is good. The students then review several related papers from the author of my choice. So try and find a project and focus on 2 or 3 recent papers in that particular area. It depends a bit. I've had students do great reviews on a single paper. Some have been up to 4 if there are a bunch of communications that are related. So that's somewhat variable. But essentially, I want them to tell me, what's the theme linking them, what's going on, what's the author trying to do, what they find, that sort of thing. Ideally, then, somewhere mid to late in the semester, we'll have the person pay an in-person visit, give a seminar, and spend some time meeting with my class. Past few years, that's obviously been kind of Zoom, but that's sort of nice because I have no budget to do this. So when people have come in person, it's relying on the goodness of their grad recruiting offices to help them out. But I do want some time with the author of my choice for students to get to meet them, talk with them, interact with them. The second paper then is a research proposal expanding on their first paper. So take the work that's been done and go in a different direction. Sometimes that direction is, not exactly groundbreaking, earth-shattering kind of stuff. It's logical, but it's not quite methylphenyl feudal kind of stuff, but akin to that. Sometimes students get really inspired and just go in completely different directions, which is great. I want them to have freedom to think about whatever they want to do. So I'll kind of close up with kind of the future, reflecting on the course, where it's going, what I'm thinking about. I don't expect too many changes coming this fall. And there's a big reason for that, and that is that it's going to be the last time I teach it in its current format. We recently adopted a new course schedule that will take effect, as far as I understand it, in the spring of 2024. This course is a fall course, so it will affect me for the first time in fall of 2024. And this new schedule is going to allow on Monday, Wednesday, Fridays. What were traditionally 50-minute blocks, there are going to be a couple blocks that are going to allow for 75 minutes. So I, in the future, will no longer be able to do the 4 50-minute days. I will be transitioning to 3 75-minute days. So I do envision that is going to have a significant impact in the class in the future, in how I think about it. So stay tuned for that. But that certainly doesn't inspire me to go crazy and make a bunch of changes for this fall, as more changes are coming. Things I think about, though, that, I do want to address. NHCs are a little shortchanged in my process. I mention them for sure when we get into metathesis catalysis. NHCs come up, but I do feel like I could probably give them a little bit more time in the class. So that's something I'll probably be looking to address in the future. Could I cut out some of the material and get more catalysis in? Probably. Carbonyls are one of those things that they're traditional, they're great. There's just so much to appreciate in their bonding. Do I spend too much time on them? If you flip through a current issue of Organometallics, do you see a lot of metal carbonyls still? So I'm a little torn there. It'd be hard for me to get rid of them, but maybe it is time to get in a little more catalysis. I don't know. Do I need to spend some more time on polymers? We do spend some time there, but I think I could spend a little more time on talking about the numbers in the triangles and what all of that means. Get into tacticity and some of those other kind of issues. It's not something we do a great job covering in other places in our curriculum. We've apparently done a good enough job to convince ACS that we're doing an okay job with it. But maybe I could slip in a little bit more here. I wouldn't hate it. I don't know that I want to do it. Time will tell. And, I do go to the Organometallic Word and Research Conference, so I do like to pay attention to what topics seem to be really hot with people in any given year. So I do think that is going to continue to shape the course as it continues on. I want to make sure students are seeing what's captured people's attention at this point in time. So with that, I have ended the formal part of the presentation. And I will stop sharing my screen. I think maybe we'll keep it up for a moment, but I would certainly entertain any questions, statements, comments, anything we want to talk about at this point in time.
I'm interested in your tour de force of ligands and also of reactions. If you could just flesh that out a little bit for me. I mean, I don't teach a full semester organometallic course like this. I just do the 2 chapters out of Housecroft that, there's the organometallic chapter, and then there's the catalysis chapter. So I'm just curious as to, how you manage the ligands and the reactions.
Sure. So with the ligands, right? Carbonyls and carbonyls are first for a particular reason. The concept of orbitals that are antibonding being bonding blows students' minds, and it's trying to get the point across of, yes, they're antibonding, but antibonding with respect to what? Right? They're carbon-oxygen antibonding orbitals, but they're carbon-metal bonding. So we spend a fair amount of time just talking about that overall interaction and looking how it impacts the IR. You show them there first, like, here's the IR of free carbon monoxide at 2143. That's not where you think of COs from in Orgo, right? You think 1600. And here's a metal carbonyl, and look, they're at 2000. What's going on? We got to appreciate that there's a lot of carbon oxygen triple bond character there. But then we can talk about donation into the pi star and all that kind of stuff. And that then sets us up to, okay, you put an alkyl on a metal, big deal. But you get to ethylene. Oh, how does ethylene bond? We can talk about what are the most available.
You preface all that then with some MO development? Is that right?
We do a little MO development. There's certainly the expectation that they've taken the sophomore course, so they should be able to handle the MOs of CO, for example. With ethylene, it's hoped they get that in some form in Orgo to at least a little extent, or at least I can usually get them with are there any lone pair on ethylene that can serve as a bonding pair? No. Okay. So what do you think the most available electrons in ethylene are if I'm telling you it's bonding to a metal? And they'll usually come up with, well, it must be the pi electrons. So, once you kind of get through carbonyls and ethylene, then going to things like CP and benzenes bonding and alkylidines and those sorts of things are not too big of an extension. So we start to go downhill there and spend less time with other things until we hit hydrides. Where we got to talk again about kind of, okay, you're using bonding electrons there. But at that point, they've seen enough. So it's definitely a less time as we progress going through the ligands. But it's mostly is in that tour de force talking about their bonding interactions. And then kind of at the end, like, okay, here's the characterization aspects to think about. Reactions, then again, I would say the reactions take, I would say, about 2-3 weeks overall to go through. Substitution, I don't have to spend a lot of time on. It's just hey, you've learned these words or you've learned these reactions in Orgo. They just had different names, SN1, SN2. So I don't have to live there too much. Oxidative addition, reductive elimination, we spend quite a bit more time there because it's a different kind of concept. And we tie those back to electron counting a lot. So that one takes a fair amount of time when we're talking about reactions, as do insertion reactions, because that's some weird stuff. So we go through sort of mechanistically how that's going on, or how the product distribution is affected. And then nucleophilic attack, that again kind of ties back to Orgo. So I don't spend as much time on those reactions. Adam's got some great comments in the chat here about blowing people's minds with back bonding in PF3, sure. And the Kubas paper with H2. H2 is a great discussion. It is. I use kind of the results from that to talk about in class. I don't do the full lit discussion. It's one I've certainly thought about, and that's definitely fun. Madeline's got in here that spends a decent amount of time on CO ligands, group theory, vibrational spectroscopy. Yeah, I don't know what other ligands molecules I'd use to introduce. I couldn't get rid of COs entirely. There's no way they could go away. I just like talking about them too much. I just worry I talk about them too much overall in the bigger context of things there. And then Madeline's also got a point. Do I consider diversity inclusion in the papers you choose or the inorganic prof of your choosing? Yes, I certainly do make a lot of attempts there. In particular, our majors have traditionally been about 70% women. This fall, I have 10 people in this course. they are all women. So I am most certainly going to choose a female identifying chemist for this class to be the speaker. And over the years, most of the speakers I've had in have been female identifying or part of an underrepresented group. So I think that's an important component of it. For sure. As far as the papers go, I certainly do my best to, not just choose papers from any specific type of group or anything along those lines. It's very topic driven. So, if I can find 2-3 papers on a topic I really want to talk about, then I'm going to choose an author that is greater for inclusivity and diversity. With the Monsanto acetic acid process, for example, I'm kind of stuck there with what I got to choose.
So Chip, just to follow up on this question, because it gave me an idea and something that we could maybe crowdsource in the Viper community.
Sure.
Would be, so I'm teaching Organometallics as a master's level course in the fall, most likely. And I have a list of topics. And then what I did was I chose a quote unquote seminal paper and then a secondary paper, a more recent paper. And it was much easier if I was choosing something more recent to choose a paper that would be fit a DEI model of inclusivity. And I wonder if we could somehow post a list of topics and then just have people send ideas of papers that they like that would broaden the diversity and representation for these different topics. Is there a way to do that?
I think there's great ways to do that. So what I'm envisioning right now we could do is create a Discord channel to do that. And for anyone who's on the meeting now or watching this later, if you're not familiar with our Discord channel, go to www.ionicviper.org. In the top, there is a link to our Discord channel to, oh yeah, Madeline totally just volunteered to do this for sure. But I think we could start a Discord channel to get the initial discussions going and see if we can get people to talk about it. And then what you're ultimately suggesting, I think, is that on Viper, we create a collection. So there are certainly going to be some existing literature discussions there that would fit into this. And, in this collection, I don't think we can do it easily where it would be we could list the topics and then under each topic put the specific literature discussions we wanted, but I'll think about how we might do that. But we could certainly make a collection of, here are seminal and more modern examples of these important topics. I think that's a great idea.
Yeah, I would be very happy. In terms of what I have volunteered to do, I'll be very happy to share my list of topics and the list of papers that I came up with the first time I taught this.
Okay.
It's a little outdated because I haven't taught it. I only taught it once and I taught it in 2018. But then maybe we could build from there. I think that would be really cool. And I think in terms of building literature discussions and thinking about representation, I would love to have other people search, but also to make it so that not, when you're looking for something, you don't have to look very far.
Mm-hmm. Yeah, no, I will make a mental note.
And there's certainly some really good foundational papers already on Viper, both from the article that Drew and I wrote probably in 2008 now, and then the one that we wrote just a couple of years ago. But yeah, the newer papers are always the ones that, I'm so out of date, the papers I'm reading are so narrow and focused that for me to find a paper on a new topic, or an update on an old topic. It's just I'm just swimming through the sea to try to find something. The papers I wrote are on Viper, but I'll look for them somewhere. I'll send you an email or something, Madeline.
They exist.
The other thing that I was at a conference for a completely different other thing recently, where I was talking about getting students to take ownership of their class, and it reminded me of something that I did, boy, probably 15 or 18 years ago, called the diversity pamphlet or something like that, which is on Viper as well. And I had the students pick a chemist, an inorganic chemist that embodied I didn't force them to pick someone who embodied diversity, but I encouraged them to do that. And they wrote little pamphlets on the person, sort of their life and story. But I think in terms of writing papers, because I'm going to add papers to my class this fall, and I think I want to give the students an element of choice there to let them sort of, I can give them some examples of people that maybe they're not going to think of, or if they really want to find, whatever, a specific minority group, I can help them find someone. And I think that ownership would allow them to really, and then I'm thinking about that, assembling all that into some sort of, it used to be an old, like actually would print them out and give them out as a book, but now I would just do it electronically. And that would be cool for the students to have this little resource of people and chemistry that we learned about.
All right. So let's see. I've got homework. Make sure we get a channel created. I can make that happen. And yeah, no, I love the idea. I think it's great. Any other questions or thoughts people might have? Happy to try and address them.
I had a question related to the paper
Yeah.
that you have. There are the two papers. And I might have missed something. So on the first paper, what was that a summary of the topics, or what was the first paper again?
Yeah, it's mostly a summary for them to get familiarity with someone's work, and serve as an inspiration. So it's essentially reviewing a very narrow field, is what I have to do.
And with that, do they get to kind of pick and choose what piece of that person's research they do?
Yeah, so it's, my encouragement is usually, hey, take a look at the person's website and see how they break it down. Do they list their various projects? If that doesn't work, you might go into SciFinder and do a dive on their publications. It has occasionally backfired. It's not quite the right word, but I had Jillian Dempsey as our speaker a couple of years ago, and one of my students somehow found a project that she was co-author on a couple of papers on with someone from her physics department, where she made some minor contributions, and for whatever reason that just attracted my student in that direction. So they're all of a sudden they're like, well, here's my first kind of draft and idea, and it was like, wow, okay, wasn't expecting that, but that was cool. The student found something new and interesting.
Yeah, no, it's interesting. I was asking because I also had something back where I let them go full rein on anyone, and then I had to read 10 papers, and that consumes a lot of time. I like that idea of focusing in on one specific person, at least on their topic. And then how many times do you go through that iterative writing process? You just read one draft or part of it, or?
So I don't actually make rough drafts part of grades assessment. So I will generally tell them, like, the rough draft is here to help you. If you want to hand me a sentence, that's fine. That's a rough draft. Don't expect a lot of constructive criticism on one sentence. Usually what will happen is they'll give me something for the initial due date, and then the week before their papers due, there'll be the beg. I've got something a little bit more. Could you read it? And generally I'm able to. So usually it will go through too. You know, in a class that size, there's usually one or two where it's like, I don't even need to see your rough draft. I know it's going to be fine. But
Okay. But you're saying you don't do any sort of grade, even just a completion grade or anything like that at all?
no,
Okay.
I think they get enough feedback to know if they need to make significant changes or not. And
Okay.
it's for their own benefit. Yeah. And when I initially did this, I had started it with, here's a list of a whole bunch of inorganic chemists, choose whoever you want. And like you said, I couldn't keep it all straight.
Yeah.
And then I got the idea of like, if I only do one and can bring that person in, how much cooler is that? The students are going to be all familiar with someone's work. They're going to be able to ask them insightful questions, and that's why I bring them in late in the semester. I can see the argument to bringing them in early, but I bring them in late when they're really starting to think about their proposal part of it, so they can actually like, hey, I've been thinking about this, or that aspect. I like that.
Well, thank you.
All right, I see the chat is blowing up a little bit, but I think it's just Adam providing information. So it looks like.
Yeah, I don't know if we want to put those as links under the YouTube. The other thing I wanted to say is I do a very similar course. If you looked at our courses from the 50,000 foot view, I think you wouldn't be able to tell the difference between my course and Chip's course. But I do a lot less lecture, and we jump right into literature discussion. And I have some posts on Viper that I can't find right now where I talk about how I grade and evaluate the in-class discussion, because I couldn't figure out how to make it happen. And it's something that's called a Harkness diagram. And so if you look on Viper and look for Harkness diagram, you can sort of see how it works. But I have one student who scribes the conversation. So they write the list of all the people.
Talk about humanizing a rat. Look at a doorway or a window,
someone's there.
I got it.
That was weird. So the Harkness diagram, they just sort of trace the conversation. And so if you have a lot of spokes coming out of you, it means you're dominating the conversation. And if you never speak, then, hey, next week, why don't you try to speak? And why don't you try to speak less? And I just have the student post that up to the class, website. And then the other thing is I have another student who sort of describes the conversation just really shorthand, like what we talked about. And so those two people are excluded from participating in the conversation. And I sit actually outside the circle often. I don't participate unless it goes off the rails. Now, anyone who knows me knows that I tend to make it go off the rails. So I do try to re-rail if they go way off track. And then the other thing I do is an oral final exam, which the students are terrified of. But I tell them it's good practice for grad school, for giving a group meeting, for giving a presentation to your boss if you go work in industry. And then once they do it, they realize, oh, that wasn't so scary, because if they get stuck, I give them a hint. And that way they don't lose all the points on that question. They actually can, I don't remember the MO diagram for this compound. So I give them the MO diagram, and then they go off and they can answer the question. And so it turns much more into a conversation than a scary evaluation. So students tend to like that.
I think I might have to look over your assessment of lit discussions again, and think about adopting that for sure. Yeah, Claude.
Did you say much about heterogeneous catalysis? I can't remember now here in your presentation.
I do say heterogeneous catalysis in the class a few times. Mostly it's when I first introduced the idea of homogeneous catalysis, we compare them to heterogeneous catalysis and the advantages and disadvantages of each. And then there are a few reactions where we do, some transformation syngas kind of stuff, where we talk about heterogeneous catalysis as yeah, this was done with a heterogeneous catalyst, and we move on there.
You don't do mechanisms.
Don't do any mechanisms, no, and that's probably personal bias of I do solution kind of stuff, so I live homogeneous more than heterogeneous.
Okay. Yep. I was curious about that because
Yeah.
you've got yep. That's good. Thanks.
All right. Well, we're coming up on the hour, but I'd be happy to take any other questions, comments, or thoughts people might have. Like we've got some action points to work on, which is just awesome. I'll get that channel created when I talk to the powers that be.
Well, hey
Yeah.
Chip, one more thing I might
bet.
mention. It's a comment, it's not a question. But,
That's fine.
So I teach my organometallic class actually it's not a requirement. So it's for master students and then students who've already taken an advanced inorganic. So they've already gotten some of the group theory work. And so I actually, instead of going straight into like catalysis as like a full thing, I break it up and do oxidative addition and then reductive elimination. And we actually go through like the pieces of the catalytic cycle and then build into the full, picture of catalysis, and then do the literature discussions after we've done that so that they can recognize those pieces as we're looking through the literature.
Mm-hmm.
But and in doing so, I end up teaching the first half more like of a traditional course with worksheets and lecture and quizzes, and there's like one exam, and then the second half is all literature based, so that the two modes are completely separate. But it sounds like even so it's covering a lot of the same material, so that's actually very comforting.
Well, that's good. Yeah, I think I think the biggest hurdle for me to commit to what Adam does more, and sort of what you're describing is that writing component of the class. There's only so much I can ask students to do, and I think with the 8 literature discussions and the 3 or 4 papers and whatever outside material they're reading to write their papers, I don't know that I could push any harder on that. And I think the writing component of my class is important for big picture and little picture reasons. The big picture reasons is I think it's a great experience for them to, like think outside the box, and be creative and do that. I really like that aspect to that, but there's also the practical side that if I don't have 5 people in my class, I don't get full credit for teaching it. And biochemists aren't going to take the class if they don't have to, unless they get something for it that they need, like a W course, which is something they need to graduate. So I'm not getting rid of the W anytime soon. So that's something I got to work around.
Thank you.
Yeah, thank you all. With that, I will stop the official recording.